Okay, my friends, hold on tight. We're going to be going to take a look at stromatolites. They are what they would call concretions. They're these balls over here, and they're all over the place. I mean, they're everywhere. And I don't believe that they are what they think they are, and I will show the evidence to support my side of it. Then I would like a response from the geological community, which is required if I can come up with evidence to show that they're wrong, and I absolutely can, and I will right now. Okay, my friends, this is going to be a lot of fun. This is Hunstanton Beach in the United Kingdom, and my friend Neil is over there, and he went directly to the source, and he's shown right up close and personal. Now, this is from the internet. I don't know who took this picture, but what it's showing is what they call stromatolites, which are these balls. This is just some kind of mud, which is run off from this red wall here, and then this white cap has come down as everything gets eroded away. They say these balls are just growing here. They're actually in this wall. And they are eroding out of the wall and just dropping down. Now, let me show you what Neil sent me. All right, this is fabulous work by Neil Longren. And he contacted me, said, can I help you? I'll go out and take some pictures and do whatever you want. He sent me stuff if I want it. I don't need it, but I really appreciate his help and going out and getting this information, because this is important to see this really up close and personal. I know what it is, but to have somebody on site is much better. I don't have the ability to do this myself. Everybody's, oh, you should just go do it. No, I don't have the money. I don't have the time. I don't have the inclination. I study what I can easily understand by seeing it. I don't have to touch it. And somebody can do the chemistry on it. I'd love to have somebody do the chemistry and do the metallurgy. Like this right here, I think is another membrane. And I believe that is probably like an aluminum material, because phospholipids are membranes, and they boil down into aluminum silicates. And I think this is aluminum. And in between is the bilipid layer, the fatty layer. I'd love to have somebody be able to do this stuff, but I don't have the resources to get it done. Anyway, you see, we're talking about stromatolites. These are 12 most mysterious things scientists can't explain. There's so many things they can't explain. They make up all kinds of things. All of these balls are completely moss green. And they are everywhere. They have no idea what to think about this. I know exactly what it is. Okay, I might as well hit you with the big guns right off the bat. I'm going to tell you right now, this is biology, and this right here is interstitium. These balls are part of the biology that keeps your flesh in position. And this was at one time flesh. Now, they also are on top of organs. And this is exactly the same stuff as the other one. Now, this is probably skin as well, because there's so many of them all in one. I mean, they're just everywhere, all through this whole thing. Now, this is what it's made out of right here. This is basically is what your skin is, underneath your skin. All right, and this also equates to on top of a organ. There's going to be a mat like this. On top of the organ, there's going to be a membrane that can pull, and I'll show you that in a second. But underneath, there's all these webbing and all of these balls. And those balls anchor, and they have straps, the little brown straps. And they can pull this way and pull that way and up and down, but you always pretty much come back to where you started from. That's what all these little tiny balls are inside of tissue. Now, where are these balls inside of the earth? Well, they're all over the earth, first of all. These are the Moki marbles. Moki marbles are interstitium. They're the same as this, only they're from a smaller creature. Now, this all eroded away, and the mud has washed away. This is eroding and turning into mud underneath, right down here. This is all mud. And these are the balls, the same as these balls. So that's what we're really up against here as far as stromatolites go. Stromatolites eroded, I call them tendon balls. They're anchors, they're enthesis, there's all kinds of names. Everybody now is starting to call them tendon balls. And that's what they are. They're little locks that lock things. You could consider that a tendon. It's locking it in position. It can do this and do that and do this, but it comes back where it's supposed to. Exactly what a tendon does. A tendon gives you a little bit of bump, and that's it. These are tendon balls. Now, and they're everywhere. They're just everywhere. I mean, everywhere. Now, let me show you something. This was unknown until just recently. 2018, they did this Meacher interstitium, Newfound organ. Well, what is it? It's this layer right here. The fluid runs through there. And it's just above your fleshy layer and your membrane underneath. So the thing's trying to penetrate through. The first barrier they come into is the interstitium. That is your layer of immunity. Inside of here, you have to have your bacteria, your enzymes, all that stuff to fight off invaders. Now, in your guts, you have the same sort of stuff, but you also have enzymes that are attacking food and so forth that's coming down along that layer. Out here, this is the protective layer of skin. But inside your body, you have a layer of interstitium right on top of your organs. Same thing, when you penetrate through that interstitium, get down into the organ, then you're invaded. And that's what cancer is invasion of a membrane into the organ, and then it turns into a tumor. Now see, this is from Neil Lonergan. That is that interstitium layer. This is the fluid-filled highway that floats between the out area where you can get invaded a little bit, it won't hurt you too much, because these come to the aid. All this fluid comes in with all the bacteria and enzymes, it kills the stuff. And underneath is your vital flesh. Now, I'm going to show you a whole batch of pictures he sent. He did a nice job, and I appreciate it, Neil. Thank you so much, my friend. Okay, this is a membrane. I'm going to show you in detail. I believe this is too. And this is the top surface and the bottom surface. They're basically made out of the same things. And they boil down into aluminum silicates, and I believe that's exactly what we have here. And you can see some of the red, meaty stuff that's still attached here and at the top a little bit. I believe this is the skin area at the top. See how wrinkly it is? On the bottom, it's more of an adhered area. Now, but anyway, I'd love to have some chemistry and metallurgy done and all that stuff on my things. It's expensive. I'm not going to do it. Now, this layer right here has to be glued together, so glued tightly. It's called tight junctions, so that you can move and squish all around and do all these kind of things, because you have to move in your body, and everything has to be stretched and pull, but you cannot make a gap between these bumps. Now, let me show you Tyson stuff here. Now, Tyson is on the west coast of the United States, up in Oregon. Now, here's I showed you the membrane. Just think about this. These are these balls. These are the balls. These are the balls. These holes here, these protein channels, these are the protein channels. That's how big this creature was. This is 6 feet between this layer and the next layer up, I will show you. So this is this layer right here. Then you got a whole batch of stuff that's eroded away, and then there's another layer up here, 6 feet up on the wall, and here we go to the other layer. Here it is right here. There's the second layer up. All right, so coming down through here, I don't know what this was. It appears to be an organ of some sort. I don't know. But now, here's the key. When I talk about cellular junctions, first of all, this is the membrane. This basically is the same thing as this. All right, now, all that stuff just eroded away. This white stuff just eroded out of there because it doesn't have the integrity that the membrane does. Now, look very carefully at these little edges. You see those little edges around there? Why would you think that would happen? What's that all about? Why would they have those little bitty edges around everything? I can tell you why. Because the small leucine-rich proteins, which is they call Slurpees. It's a gummy, slimy, gooey mat that would have been all through here. And all of these things would be able to do this and this and do all kinds of things, and then the gooey stuff would keep them glued together. And from here down, right up here you have there's tight junctions are at the top. This is where your tight junction is. A little below that you get to what they call the adherons, and then there's another one, I forget, but anyway, there's 2 more layers below that are glued together, and they have like fibers in them, so that they cannot separate completely. But if you don't have the gooey stuff at the top, and inside this ball right here is where all that enzymes and proteins exist to attack things coming through. I'd love to see what the chemistry is inside some of these balls, because this is where enzymes, and I'm telling you, I got things here still got catalase in them, which is an enzyme that it cleaves off extra oxygen, and it's still good. It's the catalase still works fabulously fine. These enzymes might last basically forever. So, and this is where they're supposed to collect in what they call this apical membrane here, the top side of the membrane. Now, that brings up a good question. Would that be the top side of the membrane, or would you'd have to come up to the top side of this top membrane? Because that's where most of your enzymes should exist, up here. But probably there too, I don't know. But coming in, this would be the first line of defense right here. So I would say you'd want your enzymes and your bacteria primarily up there. This is sort of a mat to float around and do all these things, but up there is really just seals you. That one there, you shouldn't be able to break. And I don't think you should be able to break that either. Not according to what they claim the biology is. They're basically the same thing. I don't know. There's a lot of work to do here to dig into this. Now here's another one of Tyson's. Now this is Tyson's Mudfossil Adventures. And this right here is one of the tendon balls. And that right there is the strap. They all have little straps. Now, it depends where it is in the body. Like I say, some of them are on the membranes that coat things, and they're anchored, because some of the membranes, like on your lungs and your heart and all these things, they're expanding and contracting, boom, 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 all day long. So you have to have something that has a strap to it and a ball so that it can pull and come back. And that's what this interstitium is, and it's everywhere in your body. 100% of your organs, your muscles, your tendons, your eyeballs, everything. It's a newfound organ, and it covers everything in your entire body. They claim now it's the biggest organ in the human body. This is 2018. I was studying this same thing, and I knew exactly how it worked, because I could see it. And that was in 2015. I wrote a paper about this called fascia-facilitated fossilization, because that is the fascia there. And at that time I said it was a fluid-filled network. It came together as one giant system, and it does. And that's what the paper says. All right, everybody's seen this a million times. This is my hair follicle from some kind of big creature. That right there is the erector pili muscle attachment. This right here is the sebaceous gland. That's where the hair shaft comes up to the top. This comes down to the root ball, which is right down there, and those 2 little dots are what they call the hair papilla, which is really the vein and the artery coming in at the bottom, those 2 little dots. So this is pretty good size. And I just find these things, and they're on top of the surface of the earth. They're not buried. They're not even buried. So how could they say these things are 500 million years old? Plus, how do they account for giant creatures like I'm showing them? The earth was constructed of creatures, or is a creature, or both. All right, you people have been with me for a while. You know about mud fossils and layers of tissue, and how you have the darker and the lighter layers, and then you have the little tubes that feed or pick up blood, which is called the veins and the arteries, and then you also have layers which are membranes that are saturated with fatty lipids and so forth. They call this sedimentary rock. They think this all formed in layers from some washing down the hills. Same thing with this. They think that's all just layered rock. You see these tiny little layers? That's biology. That is not just rock sedimentation. Ayers Rock, Uluru, is not just one big red rock either. I know exactly what it is. It's a heart. And all of these different things, when you see these different little bitty lines and waves and so forth, and that's not just happened by accident. Like this one here, let me show you something. These here, here's something that's, my stuff is small, but if you know what to look at, you can see all of the same things that are in the big ones or in the small ones. You see all that? There's so many layers in this, it's absolutely unbelievable. Now, the creatures that they're dealing with are so big that the rock layers are just enormous, absolutely enormous. Yeah, that's biology. That, my friends, is muscle. All right, now this is up on Mars, and Curiosity is up there, and Curiosity has found this right here. This is exactly what Curiosity found. Mars blueberries. Same as the Moki marbles. You know what else they found? They found a Mars Morse code. Looks identical to this. Mars is literally identical to Earth. And that's why I said, oh, yeah, this is all on, what's that place? Devon Island. Well, Devon Island could be exactly identical, yes. But the key is, there's not one bit of erosion. You can't find any rivulets up here. None. Zero. Zero. When I show you the Mars Morse code, you can see it's just somebody like just barely dusted it off. It's never had one drop of water hit it. As is this the same thing. This has been thousands of years, about probably around 3,500 years ago. Mars was impacted by Venus. All of these things that were written in the past about giants and creatures that are just monstrous, it's true. It's just true. Look at this. This is over in Iran. Steeply dipping sedimentary rock strata along the Kelos Road in northern Iran. If you look closely, you see all these little dots, dot, 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 dot. Those are sarcomeres. You see all those little dots? Those little, every one of those little stripes is a fiber. And in every one of those fibers is either tendon fibers or muscle sarcomeres. Now, I'm not sure which. But one way or the other, I think it's probably tendons because I don't see much blood. If it was muscle, you'd see a lot more blood. You see a lot more red. But I do see some spots that look like, well, let me put it this way. There's no question whatsoever. This could be easily looked into. And I think some of the, like that spot right there, I think that might have serviced some blood in there. But all of those little blocky looking things are from a fiber. You see, these are iron oxides. The red is your artery and the black is the vein blood. They call it banded iron. Well, why? Why? Explain to me why. I know exactly why. And as a matter of fact, hold on, I'm going to show you an artery. All right, check this out. They say these are unfixed stromatolites, and they show all this. That is red blood. And this, my friends, is an artery. This is a gigantic artery. That is red, just nothing but red blood in there. Now, I filed this down flat, and I got some shots in the microscope. I'll show you the layers of what an artery looks like. Hold on, and the anatomical. This was sent to me by my good friend Greg Morrison, and he sent me a bunch of stuff. And he's down on the East Coast, I believe he's down in Tennessee area, somewhere down in that area. And he goes here and there, and he sent me a lot of stuff. He's a nice guy, and interested. Never going to get anything out of it, Greg, but I appreciate it, buddy. All right, so that's the spot that I sanded down flat. Otherwise, you really can't see a whole lot until you get it nice and smooth, saturated with water, and then through the microscope. So let's look at that. Now, think about this now. This artery that Greg sent me is just an artery. In you, they're small. The big ones are, not any bigger than that probably. This is as big as my upper arm. This is enormous. Now, for an artery, I mean, it's just gigantic. Now look at this. Here's what it looks like, an artery. You see these layers? And then you get into the red, that's this right here. And that's that spot that I sanded off right here. All right, and I took a picture of it in a microscope. Hold on, let's get I got another shot of it here. All right, so this is the outside edge. And then inside, as you go in deeper and deeper and deeper, it gets to where the red is in here and all that. That here is just nothing but red. All right, so we're looking at this depth right here. Now, what would it look like if it was in a living creature, or what does the anatomy look like? Well, it looks identical. It's just identical. I mean, it's so identical, there's no possibility it's not what it is. It is what it is, and what it is what it is. And it is saturated with blood inside there. And this right here is that wall. And this side is hollowed out more, but it's just nothing but blood in there. There's still a lot of blood in there. It was, you know, at one time it was just packed. Now, I don't think he broke that off. I don't know how he got this out, to be honest with you, or how he found it, but it looks like it was eroded away. It came just as clean as could be. I didn't wash it up or anything, I don't think. So I don't know how he found this, but all my stuff has been on the surface of the earth. Basically, I almost dug for nothing. A few things here and there, but it's not 500 million years old, this stuff. And plus, there should have been nothing with an artery that big. There's just nothing that could possibly account for that other than the old ancient texts were correct. There was giant creatures on the earth, and the earth itself, they claim Gaia was a creature. And all kinds of things claims in the past we have to reassess now. I'm not trying to make waves to make people unhappy or destroy their lives or livelihoods. I'm just trying to find truth and reality, and that's all. That's all. And I think I found a lot of things that we don't understand. And in order to understand them, we have to discuss them. And I can't find many people that are willing to make that discussion. That's a leap that you have to bring yourself into with an open mind and watch and listen. The problem is people won't even watch. They absolutely, no, I don't want to see it. Don't show that to me. I'm happy where I am. And that's what I've gotten for 15 years. So I guess you're okay if you want to do that. But if you're here watching this, I don't think you're okay with that. I'm certainly not. I want to know what's the truth. Everything is about truth for me. I don't care. It's tough. Sometimes this has been a hard road. I'm going to tell you right now. This has been 15 hard years, and the pushback has been so beyond what I had expected. Anyway, I don't want to get into that because that's a little bit of a bitter issue. But let's do what you think is right. But I'm going to show you all these things, and I keep showing them every day. This even right here, coral. We don't even understand coral. You look at that and you say, "Oh, that's just coral, Roger." No, it isn't. It's just coral. That's a heart. That was a heart, and it still has blood in here. That has crystallized these red crystals. I'm going to show you in a microscope. There's the chambers of the heart, and here's the valves of the heart coming up the top. This is where the plumbing came out. I don't know what kind of creature it was, but that's where the valves of the heart were, right there. And it would go and squirt up through these valves. Again, I could show all this stuff, but you have to have an open mind. Like, oh, no, that's not what it is. Well, let's take a look at it. That's all I'm asking. And then when we sit and we discuss and we think and we go from there. Because I have just way too much evidence. Just so far, the evidence is so incredible. It's just beyond anybody's ability to deny it. All right, here's your little blood vessel right here. Those are little red blood cells. I've gone deep with this. I've done my homework. So don't tell me I don't know what I'm talking about. Now let's just see what Neil had to say. He sent me, I don't know, a dozen or so pictures. And there's some of them are very, very illustrative. Let's take a look. All right, here's another shot from Neil. You see that? That's the skin has a separation right where it meets up with the lower area. And this break here, this is biology, and it has to flex. So there's like little spots that are glued together. Well, you know what? Hold on. I have a really good shot I can show you that illustrates this. All right, this is a perfect example of an abrupt transition. Above, let's say this is the skin. It's not really, this is a tendon, but it serves a purpose very well. This is the skin, and it's got these little breaks and stuff because it's going to be moving, which is exactly what this tendon does. However, at this abrupt transition, right here, you go into the slurpees. You see the little slurpees here? Which means these have to be glued together. These can't separate. So this is basically your skin coming down, and it can separate, it can do whatever it wants because it's got to move around, and it doesn't get invaded very easily. There's not a whole lot of bloody stuff. Once you get into here, you're in a different situation, so you have to be sealed up. And that's what this is doing. So hopefully that makes a little bit of sense to you. So don't forget, this is up above. This is where the skin has to sort of ride on top of itself a little bit. Apparently there's a break there that sort of one layer just separated from the lower layer, gives it a little bit of a buffer, and it looks to me. But you can see this is blocked off just as they are. All biology is like that. It's made in blocks. All right, this is that's from Neil again, and you can see these layers and blocks and so forth in the different tissue layers. You have to be flexible. Something's got to move here. So here's just some more au naturel. The skin has to be flexible, and so does this. That's why these little layers are here. They're not just sedimentation. So here's another great shot from Neil. You see, this is the wide open fluid-filled highway. I think this just may be the highway here, and this is it down into the interstitium blocks. I don't know. The whole thing could be down to here, could be the fluid-filled highway. Because, like I say, they didn't realize this until just recently. And so normally they would have had a membrane like this. Well, now they realize that on top of that membrane there's another layer here, which is in between that layer is the fluid-filled highway. So some of this stuff you got to rethink it a little bit. Like, in other words, there's your skin, there's the fluid-filled highway, there's the membrane. Before they thought there just was one membrane here with a flat mat on the top of it, because the fluid would flatten out. And they just acknowledged this in 2018. So what I'm getting at is when we go back to think about that little tiny slip of is it right here or is it this here? It could be just from here up to here. But it certainly starts here, because this is where your skin is, and right below you got to protect yourself. You can break through the skin, but getting to here, these are probably some serious enzymes in there. But you know, in the ocean waters and all that, it's a whole different story than being in fresh water. Yeah, to me, there's no question this is the fluid-filled highway, where these could be the immune cell area, and they squirt the stuff into the fluid-filled highway because it just looks like it's a web of you know, channels going through there to me, and they have to be. Even you can see these little tiny holes up here. They have to get into everything so that you don't get invaded. It has to cover this whole surface. This is a fabulous shot. Here's all the little breaks in the skin so they can move around. You have to be able to be flexible. And then right there is the absolute abrupt transition. And that, as far as I'm concerned, has to be the fluid-filled highway. And then this, I don't know whether this is water or is it just going into the basement layer. I think it looks to me like it could be water. I was trying to decide. It doesn't have to, you know, it looks like it should be reflecting something off of this. So I don't know if it is water or not. It looks like water, though, to me. That could be the reflection of this. That could be the reflection of this. I'd say it's water. But that I say is skin, and that I say is interstitium. Now you see this? This is Mudfossil. The water is so saturated with iron oxides, which is blood, the ice cascades appear to be gushing blood, which they are. And I can tell you right now, this is the kind of area that still has a lot of biology in there. When they come through from the ice, they were still in pretty good shape. Now they're starting to thaw out and gush blood out of them. These are thawing out, and then the moss takes over and eats all of these balls. That's moss, and I can show you some red blood area. You see, like right here, actually. I believe that's a little piece of red blood. I believe that's a piece of red blood. I believe that's some here. You know, there's going to be telltale signs of life everywhere. You just have to know how to look for it, and then actually go and look for it, or at least accept what is being shown. My stuff's DNA tested and CAT scanned, and I have giant human beings. I showed you I got everything. I got everything. It's all been through the mill. Nobody can deny it. So why should I continue to just keep doing the same thing over and over? I mean, I'm not going to go doing any more testing. It's you know, it's time for it to stop the denials and just challenge me, challenge what I'm showing. Say, Roger, this isn't right. That's not right. This is just normal. Well, why is this abrupt transition here? And this doesn't have any of the slurpees around it. I know why. It's because it's tendon and this is muscle. Two different situations. Now, anyway, when you got a 6 foot thick membrane, in us, if you took that membrane, which is just a slip of skin-ish looking stuff, it's thin, you can see right through it. You'd just be able to see right through it. The light would come right through. You know, I was looking into ironstone, and which is what they would call this, artery. And this could be the best ironstone that's ever been found. This is absolutely flawless. The blood is still saturated in here. The layers are extremely visible in the arterial walls. And I can't find anything that even comes close to this quality. If you have one, I'd like to see it. All right, I have something in the microscope right now. What I want you to look at is this right here. I'm going to sort of play around with the lighting and come down. This is where the entryway is into this organ. Now, let me come down a little closer here. See if we can see the edge of the transition. You see, you got to look for that rounded area here. Now, let me see if I can focus in a little better. Whoops, that's not too good. But this whole area, there's a goopy stuff that was on here holding this in. Let me back off on the light. Sometimes you can see it better that way. This area here was where the organ attached, and I don't know what type of organ it is, but I got a feeling it's a liver. And there's some red blood area. That's also part of the attachment area. That whole area there. Now, what were we looking at? Here's what we're looking at right here. All right, let me turn the lights on. Now, like I say, there's always going to be an attachment area. It's right there, and it's just gooey, and there was something attached here. Now, what type of an organ this was, I'm not certain, but there's no, I can see what's inside here, and it appears to, I got a feeling it's a liver. But this coating is the fabric that surrounds it and coats it. And there's several layers here. When you look at it in a microscope, you can see there's the fascia, then there's the interstitium, and then you right down at the basement layer that covers up the organ. This is the actual organ. And cut into it a little bit, as you can see some white spots in there. I don't know, but I got to be honest with you, I'm not sure what it is. I would say I would go with liver, just looking at it. And again, this is the area, I put a little water on there, and that's the area where it had originally attached. Now I cut this off, I don't know why, but you can see very well the membrane. I think that's probably why I did it. But you can see the membrane around here, and we'll put it in a microscope and take a look at that layer right between all of this stuff and whatever that organ is. And the same thing here. That's the layer right there. Now they say these are concretions. Oh, that stuff just concreted on top of something. No, it didn't. It was an organ. It's an organ. See, this is how geology explains this. Ironstone concretions from the rock gallery. And they say they just concreted around. It's not true. That was an organ. All right, I think this is a liver, and I think this is basically the orientation of it, something like this. And I cut this piece off here, and this is the back lobe, and this is where all the plumbing comes in down here. All right, now, they're talking about the visceral surface of the liver. That's what I'm interested in, is the surface with those little stripes that we saw. Okay, my friends, once again, I think I have more than adequately shown that these things are biological. My stuff has been tested, CAT scan, DNA tested. They're huge, gigantic human beings. And it goes unexamined. So I'm just hoping sooner or later someone will step up and do what they're supposed to do, is to examine the evidence, because the evidence is everywhere. My evidence is hard to deny if it's examined, and to have the people that are teaching be the ones that deny the examination, that's just not right. That's just not right. All right. Anyway, I love you all. Start asking your teachers. Ask your geology teachers. Ask your history teachers. What about all this stuff? How can you account for that? How can you account for that? 12 mysterious things scientists still can't explain. I'm going to tell you right now, you bring me any single thing, I mean, I don't care what it is, and I will likely be able to explain it, or at least offer an explanation, and then we can discuss it. I go from the subatomic realm, light research, actual particles of light, and their fields, and their Higgs fields, and their dipole electrons, all the way up to outer space. And everything on Mars, all biological. It's all biological. Same stuff. Same exact stuff. Look it up. Look up the Mars crab. Look up the Mars Moki marbles. I mean the Mars blueberries, which are Moki marbles. And look up the Mars Morse code, which is, well, you know what, I'm going to just show them to you. Why not? No, I'm just going to run right through them. There's the Mars Morse code. It's nothing more than the interstitium. These little balls and these straps, I showed them to you before. And this is up on Mars. This is gathered skin, stretched skin. Not a single drop of water has ever hit there. That's why I know this is on Mars. So don't start with the stuff that's on Earth. You have the same stuff on Earth, yes, but never, ever, 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 ever on Earth has there been anywhere on Earth that hasn't seen a drop of water, and this has not seen a drop of water. And the same thing with the Mars crab. All this dust that's run off of here is just nothing more than red blood cells, and there's never been a drop of water touched any of this. These are sarcomeres, which are muscle sarcomeres. That is a crab, the Mars crab they call it. That's a vein. It doesn't have any tubes coming out. The artery has all these tubes going out to service the muscle, which is here. That's the artery and the vein right there. This is up on Mars. All right, the same stuff that's here on Earth. These are the Mars blueberries. It's identical to the to the Moki marbles. It's the same stuff. No difference whatsoever. They know about this. I know they must know it. There's nobody could be as incompetent as they pretend to be. It's impossible to miss all of this stuff. And I have pushed this on all of the top universities, JPL, NASA, Lawrence Livermore, CERN, Geneva, all of them, every one of them. And they refuse to engage because it's really going to disrupt their lives. But is truth worth it? Or should we just say, oh, this is just silly, let's just listen to what the professor has to say and pay him a bunch of money and he'll give us a piece of paper and then we can go get a job. And that's basically what it's boiled down to. There is no discussion. And especially because all of this stuff supports these ancient texts and they support God. That's where it boils down to, my friends. Anyway, I'm going to leave it at that for today. I love you all. Start doing a little research. But come to my channel and look around. And just keep digging, because that's what I do. And you will see that we're basically not getting the truth in our educators. They're not educating the way they should. They're not being honest. Basically, that's what it is, honesty now. It's not to a point of we just don't understand. It's, are they going to be honest or not? And I found that they are not. So anyway, that's the end of it for today. I love you all.